Tomorrow will be better. The position of an object moving upward is given by x equals to this. At what value of t does it reach the maximum height? Dear friends, in the domain of motion, immediately we hear about maximum height, the first thing that comes to mind is the fact that when an object reaches the maximum height of its motion, there is an instantaneous velocity of 0 which it has at that maximum height. This is the idea we will use to solve this question. Follow me, dear friends. Solution. What we have right here on the board is the position vector of this object with respect to time, and let's assume that it's in meters. Now, knowing that the maximum height implies that the instantaneous velocity is 0, let's proceed by finding the velocity vector from here, which is nothing else but the derivative of this position vector. That's by definition. Okay, so v equals to the derivative of the position vector with respect to time as follows. If you differentiate this 3t, we will have just 3, and now if you differentiate 2t squared, we will have 4t. Having had the velocity vector, let's proceed by applying this knowledge that at h max, comma, v is supposed to be equal to 0. Alright, so this means v, which is equal to 3 minus 4t, should be equal to 0. Let's find the value of t for which this v is 0, and then the question is solved. So, how do we find t from here? Send all this term here to the right because I'm avoiding to work with this negative sign. This will imply that on the left I will have 3, which will be equal to the right I will have 4t. Of course, no need to say that is the same as 4t equals to 3. At this point, we just have to divide both sides by whatever is attached to t, which in this case is 4. Therefore, t is equal to 3 over 4 seconds. I go on the basis that this was in meters, so this is certainly in seconds. Tomorrow will be better.